Hello, everybody. Hello, okay. Apparently, you can hear me. Okay, we have the concurrent viewer. So it's always with it's all, hi. So, well, oh, the person left. Exercise 5.14 hard. No, like be in trouble. But I have. That's the reason I have my notebook over here and uh, I this open it open it this related exercise. It was a hard one, 3.24 uh, subsequence, which is mentioned over here. Mentioned. Oh my God. Let's see. Open it.
Opened,
Oh my God. Opened. I was saying opened at the beginning.
opened,
Opened. And what was the other one? Mentioned. Mentioned. Mentioned.
mentioned,
Mentioned. Okay. So 1.5. Opened. Opened. Yeah. Let's go back to the book. Hard. Oh my God. Implement starts with using functions you've written. It should check if one lazy list is a prefix of another. For instance, lazy list 123 starts with lazy list 1.2 will be true. Okay, and that's actually what it's a good book. I was spending some time on lead code early, but and some other platforms. But I don't. To be honest, I don't like spending time solving exercises. I enjoy. I prefer solving exercises from the book, from books, and I have solved quite an amount of them on my life, in my life. But I don't. I should shut up. If there is a fly over here, I should shut up. There is a proverb. Uh, if it shouts is the mouth, it should flies won't get in. Something like that. So perhaps I should shut up. But yeah, I prefer solving books or problems that are in the books instead of being on some websites. But those problems are good. And I am learning. I am using these platforms to refresh, to exercise some regains, well, to bring back some skills on SQL that I did have, that I have acquired some many years ago. Let's paste the type signature. Let's change. And let's paste. Since this is let's combine it because perhaps this should be the companion object. Nothing wrong with this. With the type variable is like over here. Perhaps over here. What happens if we put this thing in the companion object? Uh, say something like my empty list we start with my lazy list should be true. Starts with yeah. The problem here, hopefully you are you understand the problem is that uh, you know we need to use this flavor or this like this unfold. Let's try our yeah. So we need to if we want to operate on two lists, we need to put this back or above. But hopefully you get why why were we wrong? Which is the important thing to understand. Okay, this is wrong because of this reason. Mm, now we can use our previous approach. My empty lazy to okay. So mm, we need to define the function. Um, can we use since we have been doing a lot of work with unfold, a lot of work like 5 functions with unfold. Can we express this function with unfold? And if we don't, then we will. This is a hard problem, so we get to try several stuff. Even if it's an easy problem, you can try approaches, several approach, several approaches. And now let's. Oh my God, see the owl. Let's uh, let's see if we can use unfold. My lady Louise. Unfold. We need a state. Maybe we can use zip all and I don't like this. I don't like this way. I would like to, do some drawing. So let's think a little bit. Let's pass this prefix and some true, which will be some kind of accumulator. much. Perhaps we can take a look on that. For all, we have for all. We have several functions we can use. Case, is the empty list a prefix of some given list? The problem with this approach of using unfold uh, is yeah. The problem with unfold is that unfold will give us where is this thing? Unfold will give us a like list. No, Yeah, this is not a good approach because here is true, but using functions you have written, yeah, but we can use recursion like here. In fact, this is the solution. We can adapt this function. Let's use set with using unfold and see if we can use this as a predicate. Let's try that. This set with using unfold. And another zip over here. Fix. Let's 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 explore what's going on. What's going on here? Ways, ways. Ways, ways. We are just exploring. Oh my god! Exploring things. False, 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 false. Why? Because 200, all of these are false. Let's change this to 2. Okay, we have list of, list of booleans. Now we can use for all. Yeah, for all it returns a boolean. Maybe exist. Why will we, if we use for all, we will have to test the entire list uh, for to see if all are true. And if we use exists with one single false, it is not a prefix. So let's use exist. Or how can we? Why this in exist? Yeah, boolean. And we have this wrong uh, because my lazy list starts with singleton lazy list. This should be true. And it's saying false. Why? Because we are expressing here that there exists a false element and it's false because all of them are true. We can negate this, uh, but this seems to be the answer. This sounds like mm, let's negate this because our logic was kind of silly. Yeah, but now we need to put this 7. So we can check our this will be false, and it's true. We because we are using exist, so it seems like we need to traverse the entire list. Be, because uh, we are saying if there is a false, yes, it's here. Uh, that's not what we want. Or maybe I am not expressing this correct way, but I have started freaking out. I have started freaking out for all. Let's use for all. And then we can think, uh, this is all wrong. We have a flaw in our definition to, well, to yes, true, but this should be false. Let's explore what's going on. Explore. Oh my god, okay. These are lazy lists. Lazy lists. True and false. So this should be false. Yeah, the function we are passing is the function that they are all come true. It's a function that it always return true. So we are being like silly. We need to do something like this. And now we got false. You see? We were being rather silly. We were passing a function that always returns true. So now we can use exist in order to avoid traversing the with one element being false falsifies the entire thing. Mm-hmm. Being true false, yes. Do we need to negate the condition, but let us reason why and not just using the logic. Logic, while it is about thinking, sometimes it can refrain you from thinking, from reasoning, even when it is the science of patterns of reasoning. Reasoning. Very minutes. Okay, we're saying we have these two on hold. We want to say that we want to specify to express that for all the Boolean elements in in the list, none of them should be false. So when I generate, okay, does all these elements in all these elements exist false? True. In all these elements does not exist false. That will be false because there is one false. That's why you want to negate this thing. Now we can go back to 2 over here. And now 2 is now my lazy list starts with 2. Let's use 2, 4. 2, 2, 4. Now let's use 3 instead of 7, and it's false. Let's use my empty lazy list. Okay. That lazy list start with YAML. So we got a function implemented. We can get rid of this. Okay, and we avoid traversing the entire list with this by by using this instead of for all. Well, for all. Well, I don't. Yeah, I am was referring in the sense that yeah, these are short circuit. And this is and where is the and? Here it is. And always evaluate this side. Well, if it is false, should return. But yeah, we have our function. If you don't like to negate stuff, we'll use for all and check for true. That will be for this exercise. Well, thank you very much, and see you hopefully tomorrow. Bye. Thank you.